So I gotta say, I'm pretty darn pleased with how the trailer's turning out so far. I was kind of dreading this task of bracing up the frame because it's really no fun cutting through, you know, the pre-existing steel and grinding all that stuff out, and it's just not fun, but you know, it's something that had to be done. But overall, I'm pretty darn pleased with how everything looks. Welds on this side definitely came out a little bit better than the other side, but you know. So I ended up not putting the bracing like I was talking about earlier in between this 1x2 and the main hitch piece, just because I'm using, I don't know what thickness that is, I don't know, it looks like 7/16 inch plate, something like that. So I think that's going to be plenty strong. Like, what I'm worried about is when the crane post is on here, what type of load is this plate going to be experiencing? Well, it's going to be up like this, and the crane's going to be pulling on it like this, so it's going to want to kind of tilt down if anything. But you know, I'm also going to add braces onto the crane post. But I was worried about, you know, kind of like a, I almost want to say a torsional load on the hitch. So the idea by adding these bracing pieces is that that torsional load will be transferred further down the frame, and that'll just be spread out throughout the whole trailer. I know I said I was going to weld that jack on tonight, but before I started to weld it on there, I noticed that there's going to be two problems. Problem number one, the main post for the jib crane is going to be about there. So that handle would hit that, and the battery box is going to be right here. So I don't know if it's going to have enough clearance. No, that hit the battery box right there. I could put it up here. The only issue is that, you know, typically when you swivel these jacks, you swivel them 90 degrees, and because of this angle right here, this obtuse angle, if I went to swivel it, I'm pretty sure that it would, the foot of the jack would come in contact with that plate right there. So I think I'm just going to leave this jack off for now. Alright, here we are, day 3. I'm going to try and explain what I'm trying to accomplish today. So what I'm working on today is how the jib is going to attach itself to this 2.5 inch OD steel pipe. I figured it's much easier to build this mechanism on the table than as opposed to welding on that pipe onto the trailer and then working up above my head, which I can't really do with my shoulder right now, so I'm going to build it right here. So what needs to be done? Well, let's start with the easy part. So what's going to happen here, I'm going to drill a couple holes in this pipe to do some plug welds. And what's going to happen, I have, this is kind of like a collar. So I'm going to, it just so happens this collar like fit perfectly inside this pipe. So this collar has a 1-inch bore, and apparently the outside bore is pretty close to the inside diameter of this 2.5 inch pipe. So I figure that'll work out pretty well to center this 1-inch shaft. So this is just going to slide in here. Then those plug welds are going to weld on that collar. I'm going to have to weld on the 1-inch pipe to that lower collar, and we'll have a 1-inch pipe to pivot off of. And the other thing I need to work on is the lower support assembly. And that's going to support this brace for the jib. And that's going to be done with these bearings. So I have to draw what I plan to make onto this plate. I need to cut out a bottom section and a top section. That's going to bolt together with these, I think these are 5/8 inch bolts. And we'll see how it comes together. Alright, I'm about to cut the holes in this pipe for my plunge welds. Figured it'd be easier if I just cut these holes out with the plasma cutter. They don't have to be anything special because they're just going to be welded back in. So this is a lot easier than using the drill press. So this is where things start to get a little bit tricky. So this hole saw is about the same diameter as the pipe. This one's a little bit larger. So first thing I'm doing is I'm using this smaller hole saw to kind of mimic the size of the pipe. So I'm planning on having 6 bearings surrounding the pipe like so. So what I'm going to do is I'm going to have to cut out a piece out of this plate, but the center hole where this plate is going to slide down through this shaft needs to be larger than the shaft. So I'm using this hole saw, which this one is, I don't know, I'd say 2 3/4. I can't read the size. It's got to be probably closer to 3 inch. It's probably like 3 inch, something like that. So the hole for the pipe, I'm going to use this 3-inch section. But I also need to cut out the outer circle of this mechanism, but I also need to allow for a spot for that lower brace to attach to, and also for the winch to attach to. So I'm going to have to make a flat side here and here. So before I do the center hole, I'm just going to cut out kind of the outer template. And it just so happens that this coffee can is about the right circumference. Okay, so we have outer circumference, but we also need to have flat spots. So I need to try and find the center of this circle. Draw a line straight through. Use something like this. And on either side, and make sure that this is perfectly centered. Go to the middle. Okay, so if I draw these extensions outward, that, and I need my square. We have 5/8. Right, something like that. Yeah. Something like that. I can't see without my glasses. What I'm going to do now is I'm just going to tack these 2 pieces together, and then I'm going to take my 4.5-inch angle grinder with a flap disc, and we're just going to grind off some of these plasma cutting marks just to try and even everything out, try and get it to match as much as possible. And also another reason why I'm tacking these 2 pieces together is the next thing I need to do after I try and match these 2 surfaces. So I got to take this to the drill press. We got to find the center of this circle. We got to drill our 3-inch hole in the center. We're going to have to drill 6 holes for these 5/8 inch bolts, and the 5/8 inch bolt holes need to be dead on. Alright, so what I need to do now is I need to try and find the center of this circle now. Granted, if I had a machine shop and a water jet table, I would program the machine to cut this out perfectly, and I'd be able to program the machine to cut out the center hole and those 5/8 inch holes for the bearings. You know, I don't have that equipment, I don't have the money for that, so I'm just doing the best I can with what I have. So here's a good redneck way to find the center of a circle. All you need is a pair of dividers, something like this, or I think these are also called compasses. I'd really like to get one with a little marking instrument on the end, but this will work fine because you could use this to scratch. And what I did, I basically tried to figure out what the radius of this circle was, and then I just subtracted a little bit from that radius. And then basically what I did, I went around the circle and I made little scratch marks just at every point along the circle. Just kept scratching that in. I don't know if you're going to be able to see it on camera. I think you could see it a little bit there. Yeah, you probably could see that a little bit. You see where all those scratch marks are? Well, in the middle of all those scratch marks is where approximately the center of this circle is. So what you're going to want to do from here is get yourself a sharp punch. Put on some ears and just line up where the center of this circle is. About there. I'm going to give it one tap. I'm going to check my mark. Could go like maybe like a 1/2 of an inch this way, so I'm going to remark it again. Check it again. That's pretty perfect. Maybe a little bit more this way, so I'm going to push that mark this way. A couple hits. I'm pretty happy with where that's at, and now I'll send it home. Now we have that center marked out to the best of our abilities. It looks pretty good. So from here, what's going to happen, I'm going to take this over to the drill press. We're going to start out with a pilot hole, and I'm going to work up to this. So after a lot of measuring and a lot of calculations, I finally have the holes center punched of where they need to be. And this was really tricky to figure out, and I could try and explain it. So basically, these bearings need to be like as perfect as possible, because if they're off, there's going to be some slop in this, and I want this as tight as possible. And I know I'm not going to get it perfect, but I'm going to try and get it as close to perfect as possible. So basically what I had to do, I was originally measuring off of this, but this is a couple thousandths larger than that pipe. That pipe's like 2.5. This is like 2.56. So I couldn't use that. So what I did is I started off by taking 2 bearings, and then I took these over to the pipe and put one on either side. From there, while those bearings were sitting on the pipe, I took my caliper and I made a measurement between the inner race of either bearing while those bearings were sitting on the pipe. And then I took that number and I divided that by 2. The reason I divided that by 2 is because I needed to get a radius. So when I divided that number by 2, I got a measurement of 1.796 inches. So that represents the radius between the center of this hole and where the inner race should be. So from there, hopefully you're still following me, I needed to get the radius of the circle itself and not where that inner race would sit. So I took that, and the radius of the circle itself was 1.3725 inches. So I basically subtracted that from that, and that gave me whatever number. So then I took my caliper once more and I set it to the difference between the circle radius and the bearing inner race radius. And I don't know if the camera's going to be able to pick it up. Maybe it will. I think you could see it. But basically, I used the caliper to scribe a line for where the inner race is going to sit. Maybe you could see it a little bit. Or can you see it? You can see it a little bit right there, right? So there's a scribe mark of where the inner radius is. And then basically I had to make a scribe mark of where the outer radius would be. And basically I'm using, I forget what size drill bit. I think this is a 9/16 drill bit. Is this a 9/16? No, this is a 5/8. So basically I had to get the diameter of this 5/8 inch drill bit, and then I had to add that from this line, from this inner race, and that gave me an outer measurement, if that makes sense. So let me put a bolt right here. So the bolt's going to sit there like that, right? And the bearing's going to sit through that bolt. So I needed to figure out exactly where that bolt needed to be drilled through. So yeah, it's a little bit confusing, but I eventually figured out the outer line and the inner line. And then from there, I took a compass, and because I'm putting 6 bearings on here, I needed to figure out where those 6 bearings were going to sit. So, you know, half a circle is 180 degrees, and so every 60 degrees, I made a line. So eventually I made a line. Well, I made 6 lines, so we divided this circle into 6 sections. So at this point, I had figured out where I need to drill for the bolts. Or, well, I didn't completely figure that out, but I figured, you know, the tolerance, the inner tolerance, the outer tolerance, and what degrees, or what degree angle on the circle those needed to be drilled. And the final thing I had to do, I know I'm talking a lot about this now, but the final thing I had to do was take my caliper, and I had to divide what the thickness of this 5/8 inch drill bit was. And then after I divided that in half, I just took the caliper once more, and I made a little scribe mark, and that in turn gave me the exact point as to where I needed to punch with my center punch. So when I come back out here tomorrow, likely, I'm going to get to drilling on this, and this was one of the trickiest things to figure out, or one of the trickiest things to figure out on this project. So hopefully my measurements are correct, and hopefully that's going to be a good tight fit on this 2.5 inch pipe, and we'll move on from there.